Back to another edition of Who Wants to Be a Mathematician. I'm your host, Mr. Hill, coming at you with some second derivative test problems. Well, really only one problem. It's just going to be a really long problem because we have the product rule. Yay! So if you're given a function that has a product rule, buckle up and be ready to go because this is going to be a long ride. So we're given a let's talk about what do we do first to do the second derivative test. Step 1. Find f prime of x and f double prime of x. So find your two derivatives. That's great. Step 2. Find when f prime of x is equal to 0. Because you can use those points, those x values, and you can, step 3, take those x values, plug them into f double prime, and figure out if it's going to be a max or if it's going to be a minimum. Step 4, that's a lovely 4. Step 4, we're going to find points of inflection, so that's when our f double prime is equal to 0, and we're going to use that to talk about concavity. So step 1, find our first and second derivative. So if f of x is equal to x times the square root of x plus 3, first derivative, product rule, first times the derivative of the second plus the second times the derivative of the first. Well, the derivative of the first is just 1, so we lucked out there. So let's neaten this up a bit. We have x all over 2x plus 3 to the 1/2 plus x plus 3 to the 1/2. Well, we kind of want a common denominator because we want one term here. So let's find our common denominator of 2x plus 3 to the 1/2, because that's over 1. Finding common denominator, so we're going to have x plus 2 times x plus 3, because the square root times the square root becomes a not square root all over 2 times x plus 3 to the 1/2. If we neaten up our top a little bit, we do some distributing, we're going to get 3x plus 3 all over 2 times x plus 3 to the 1/2. So this is our first derivative. Let's write that down somewhere because we're going to need to remember that. So now let's find our second derivative. So we can do 3x plus 3. Well, let's rearrange our first derivative. So 3x plus 3 times 2x plus, nope, you know what? I'm feeling adventurous. Let's do the quotient rule. So the top times the derivative of the bottom, which would be 1/2 x plus 3 to the negative 1/2, minus the derivative, or the bottom, the bottom times the derivative of the top. The derivative of the top is just 3. That's nice. All over the bottom squared. We neaten this up a little bit. We got 3x plus 3. Negative 1/2 means it goes into the denominator. We have 2.5, so those cancel out. So we have x plus 3 to the 1/2 minus, we have a 6 times x plus 3 to the 1/2 all over 4x plus 3, because the squared and the square root cancels out. This looks a little bit ugly, so let's neaten it up a little bit. On the top, we can find a common denominator again. I know you were all excited for the first one, so we're going to do this again. And luckily, it turns out kind of nice and neat. Common denominator is going to be x minus 3 to the 1/2. So just over here, imagine this is over 1, and we're going to have x plus 3 to the 1/2 time, all under x plus 3 to the 1/2. Then we get our nice, beautiful denominator of x plus 3 to the 1/2. And this is all divided by 4x plus 12. Don't forget about that. So we can even take this another step closer and combine our numerator and make it, if we distribute this, we're going to get 6x. So we're going to have negative 3x minus 6 times 3 is 18, plus 3 is negative 15. This is all over x plus 3 to the 1/2. And don't forget about the denominator for x plus 12. Alright, so we have f double prime of x. And if we remember from before, we have f prime of x, which is going to be equal to 3x plus 6 all over 2 times x plus 3 to the 1/2. So step 1, find your derivatives. Done. Step 2, now we're going to find when our first derivative is equal to 0. Let me write down that second derivative real quick. 3x minus 15 all over x plus 3 1/2 4x plus 12. Nice. So we want to find when f prime of x is equal to 0 or does not exist. So to do that, we take our f prime, which is 3x plus 6 all over 2 times x plus 3 to the 1/2. We want to know when our denominator is 0 and when our numerator is 0 and our denominator. So 3x plus 6 equals 0. Doing some quick mental math, x is equal to negative 2. When 2x plus 3 to the 1/2 is equal to 0, well, we divide both sides by 2. We still get 0 on this side. Then we square both sides. We still get 0, so x plus 3 is equal to 0. Well, that just simply means that our x is equal to negative 3. So now we have f prime of x is equal to 0 or does not exist when our x is equal to negative 2 and our x is equal to negative 3. So now we did take that and plug that into our second derivative. So f double prime of negative 2, and this is going to tell us our maximums and minimums. So what is f double prime of negative 2? Well, that is negative 3 times negative 2 minus 15 all over negative 2 plus 3 to the 1/2, and then we have negative 8 plus 12. And if we look at this, the numerator is going to be negative 6 minus 15, which is going to be negative 21 all over 1 to the square root, which is just 1, and this is all over 4, so all over 4. So we have a negative number, a negative divided by positive. This is going to be negative. Oops, extra v in there. Let's get negative. So this is negative, so that means we have a max at x equals negative 2. So wherever that is, we're going to have negative 2 comma f of negative 2. And if we plug that into our function, we're going to get negative 2 comma negative 2. So this is going to be a max. So we have found a maximum. Now let's see if our other one yields a minimum or what it yields. So f double prime of negative 3 is going to be negative 3 times negative 3 minus 15 all over negative 3 plus 3. And we really can just stop right there because, so 4 times negative 3 plus 12. Because we know this is going to be 0. Oh, look, this one's going to be 0 too. So really, this is non-existent because we're dividing by 0. Can't really do that. So if it is inconclusive, then there's nothing. We don't know what is there. The double derivative doesn't tell us. So we only know, ding, 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 Max wins. Congratulations, Max, you are the winner. We have a max at negative 2, negative 2. So that's how we find our maximum and minimums. So now let's talk about concavity. So we're going to deal with our double derivative. So let's come back and rewrite our second derivative. Concavity has everything to do with double derivative, so it's just dealing with double derivative. And this is equal to our negative 3x minus 15 all over the square root of x plus 3. And that's all over 4x plus 12. Holy yikes! So points of inflection. This is when my double derivative is equal to 0 or does not exist. So let's figure this out. So we want this to equal 0. So when does negative 3x minus 15 all over x plus 3 to the 1/2 all over 4x plus 12 equals 0? Well, that's when my numerator is equal to 0. So I take my numerator and I say negative 3x minus 15 all over x plus 3 to the 1/2 equals 0. Well, this is a little bit tricky because we have a denominator and a numerator, so let's split this up once again. We're going to have negative 3x plus 15 equals 0. Well, that's when x is equal to 5. And then we're going to have x plus 3 to the 1/2 is equal to 0. Well, that's going to be x is equal to negative 3. And then, don't forget about our denominator down here. So, does not exist is when our denominator is equal to 0. So this is going to be equal to 0, so x is equal to negative 3. Oh look, we have two of the same ones, so we only need to do it once. So we have f double prime of x is equal to 0, or does not exist, when x is equal to negative 3 and x is equal to 5. So now we have to talk about concavity. So this is when we draw our number line and we do our intervals. Well, if we look back at our original function, we have x and the square root of x plus 3. We know that this right here cannot be negative. If it is negative, then, whoops, we don't have anything. So it becomes negative as soon as you get bigger than negative 3. So all of our x values have to be greater than negative 3, or equal to. So if we come looking at what we have, our interval, negative 3, is there going to be anything to the left of it? No, because it has to be greater than that. So we have negative 3 to 5, and then 5 to infinity, because we can keep going on further. So we're just looking at two concavity intervals. So we have to find some number in this interval to plug into our double prime to see if it's concave up or concave down. So let's pick a nice easy number. Oh, I don't know. Let's pick 0. That's really nice. So f double prime of 0, just going to have our double prime over here. It's going to be negative 3x minus 15 all over x minus 3 to the 1/2 x plus x 4x plus 12. So if we plug in 0, our numerator is, we just checking for if it's going to be positive or negative. So our numerator is going to be negative. Our denominator is going to be non-existent because it's going to be the square root of negative 3. So right there we can just stop. This is not going to work right here. So we have to pick a number bigger than 3. Otherwise we're going to get a does not exist. So we're going to have to pick a number bigger than 3. Let's go 4. So what is f double prime of 4? Let's go back to the drawing board with that one. So our top, still going to be negative, because a negative 3 times 4 is 12, minus 15, still negative. How about our denominator of the numerator? Crazy, I know. Well, it's going to be 4 minus 3, which is positive. So this is going to be a positive. And how about denominator is going to be a positive? So this is going to be a negative. So this is concave down. And how about over here? 5 to infinity. Let's just pick some big number. 10. Let's try this out. So if we come back to our function over here, we have, let's see, this is going to be a big negative number subtracted off another. That's going to be negative 10 minus 3 is 7 square root. This is going to be positive. Bottom is going to be positive. So this is still concave down because it is negative. So in conclusion, we have a maximum at -2, -2, and that's because we found when our first derivative is equal to 0, and then we plugged that -2 in for our double prime, and we got a negative, and negative means that it's going to be a maximum. We know that from -3 to infinity, our function is going to be concave down because of what we just did. This whole thing right here, that tells us our concavity. So we found our maximum, and we found our concavity. There, we are done. A whole lot of craziness, but just one problem coming at you from pre-calc and AP. What? Not pre-calc. Just ignore that.